Hey, sixth grade math students. Today we're going to talk about a way to figure out all the possible combinations of a problem. And it's called a probability tree, and you'll see why it's called a probability tree in a little bit. But first, let's consider a problem. I've got a coin here, a quarter, and we know that a quarter has a heads and a tails, and that if I flip this, I'm going to either get a heads or I'm going to get a tails. I have two choices. But what if I flip this 3 times in a row? The question would be then, how many combinations could I possibly get? Now, we could just start listing combinations like, well, I know I could get a heads and a heads and a heads, or a tail and a heads and a tail and a tail and a tail and a heads, but that's going to leave me with a whole bunch of, it's going to take a lot of work, and I'm never going to know if I'm missing one or not because I'm not keeping this very organized. So the probability tree is a way to keep things organized, and it works like this. We do something first, and we figure out what are all of the possible combinations of that thing. So we're going to flip our coin. I have my coin, and I could flip my coin one of 2 ways. It could come up as a head, or it could come up as a tail. So that's the first time I do something. I only have those 2 choices. But as I go to that second level, my second flip, each one of these has 2 choices again. So let's say I flipped heads on this first one. Now, when I flip again, I have 2 choices, or 2 options. I could get a heads again, or I could get a tails again. But let's say, for instance, that this one actually was a tails the first time, and it came down here instead. Well, what are my 2 options after that? Well, I could flip it and get a head, and I could flip it and I could get a tail. So you can see on the second one, I now have 4 different combinations, and we would read it like this. The first time I flipped, I got a heads, and then the second time I flipped, I got a heads. Or the first time I flipped and got a heads, and then the second time I flipped and got a tails. Well, but we're not flipping just 2 times. We're going to flip a 3rd time. I'm actually going to write it up here. Notice that it's growing because you're going to see what we do next. All right, so you can predict. We've got a heads. Then we flipped it. So we flipped it, we got a heads. We flipped it, we got a heads again. And now I can only have to worry about what happened in this particular case. Well, what are my choices, or what are my options of flipping? Again, same thing. Heads or tails. Well, let's say I flipped a head and then I flipped a tail. What can I get? I can get a head, or I could get a tail. Same thing here. Maybe I flipped a tail, then I flipped a head. What's going to happen here? Head or tail. Same thing here. Head or tail. And you can start to see now why this is called a probability tree. Turn it up like this, look what it looks like. It looks a little bit like a tree. I can make my trunk down here, and then I've got all my lovely branches up here. So how do we read this? Because this is the part that's really confusing. I want it to look like this in the end. I want to be able to tell what are the 3 things that I got. Well, the first time I got a head. So let's just follow this tree right here. Head, and then I flipped again and I got heads, and I flipped again and I got heads. So this tree is heads, heads, and heads. Well, what about the next one? Heads, heads, and now it's a tails. So this tree is head, head, tail. What's this tree? Or this branch? Head, tail, head. And so that's what we're doing. We're just following the path, the branches of each tree to get to what it is. This one is heads, tails, tails. And this one is tails, heads, heads. Follow the branches. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. And now I have all the possible combinations, and I don't have to wonder that I'm not missing any because I can follow each of the branches as they go work their way through. And so how many combinations do I have? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 combinations of flips that I could possibly get by flipping a coin 3 times. Probability trees don't just work for coin flips, they work for any time we're looking at combinations of things. So in this case, I'm going to look at combinations of clothes. Let's say Loudon is getting up in the morning and he wants to decide on his outfit. I want to know what are all the possible combinations of things that he could choose based on his choices. So he's got a pair of blue shoes, a pair of red shoes, a pink shirt, a green shirt, and a blue shirt, a brown pair of pants, and a blue pair of pants. And I want to know what are all the possible combinations of clothes that he could wear. Well, we can do the same thing. We can make ourselves a probability tree, just like last time. And in fact, it doesn't even have to be, it can be up and down, unlike last time. So let's look at it this way. Let's say his clothes are strewn on the floor and we want to do it this way. All right, so the first one, let's do shoes. So at the first one, here's Loudon. And Loudon wants to pick his clothes, so he's going to pick shoes. He's going to pick a blue pair of shoes or a red pair of shoes. Those are his 2 options. Now he can also pick, for his second option, he can pick one of 3 shirts. So this one is actually going to split into 3. So I'm going to make 1, 2, 3, and 1, 2, 3 branches because there are 3 shirts. There is pink, green, or blue. Red, if he picks a red pair of shoes, he could have the same set of combinations here. Now for his third piece of clothing, he has a pair options for these pairs of pants. So he can do, each one of these will have 2 branches. He can do brown or blue. Each one of these will have those 2 choices branching off of them. So I'm going to save some space. I'm just going to do BR and BL because I don't want to have to write brown and blue, and I don't really have the space. So what are his choices? How many options does he have? Well, he could have blue shoes with a pink shirt and brown pants. So he could have blue, pink, brown. Blue, pink, blue. And actually, I'm going to write them this way because I think that's going to make it easier. I'm going to edit this because I can actually write it and you can see it a little, we can see it easier. All right, so what was that again? It was blue, pink, brown. This is blue, pink, blue. This one is blue, there we go. I didn't want to have you sit and watch me do all those, so I just paused it while I filled that in. Here are all the possible combinations. If he has 2 shoes, 3 shirts, and 2 pairs of pants, he can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different combinations for his outfit each day. So he could wear, he could have 12 different outfits. out of just these 1, 2, 3, 4, 5, 6, 7 things, he can have 12 different outfits. That's the power of the probability tree. Today we're just working on combinations. We'll see what we can do with these. These are really, really powerful when it comes to coming to actually find probability. But today we're just working on finding the different combinations and the number of different outcomes. This is called outcomes because these are the things that come out of it. They're also called the probability space. Probability space. Because again, this is all the possible things that could happen out of this set of items. These are all the possible combinations. And we know it's the possible combinations because we've counted for every single thing as we went along. That's the power of the probability tree. All right, today you're going to practice making these and have some fun. I kind of enjoy these.